Good morning or good afternoon, a few seconds. Hi.
All right. Hey, welcome everybody. Welcome to another Destination Space 2021 incredible brief talk. Today we have Dr. Fernando MierHicks from NASA Jet Propulsion Laboratory. Dr. MierHicks is going to be presenting Getting Perseverance and Ingenuity Ready for Launch. My name is Andres Martinez, and I am an engineer here in NASA here in Silicon Valley. Welcome back. We're going to get started. Please help me with a virtual welcome to Dr. MierHicks. And remember, we only have one rule. We have to keep our microphones muted, okay, so that we can be courteous and allow for our amazing speaker today the courtesy of sharing his amazing work. All right, welcome, Dr. Fernando MierHicks. You may begin. Thank you.
Thank you, Andres, for the introduction. Very happy to be here. Very excited to talk about this. Well, I'm going to be talking about how we at the Jet Propulsion Laboratory get rovers and now helicopters ready to be launched for Mars. Right. This is a very peculiar time because tomorrow, actually, the rover that we just built in the past couple of years is going to be landing on Mars tomorrow. So whatever you hear and learn from today's talks, if tomorrow you tune into nasa.gov or YouTube, you're going to be able to see the landing of this very, very cool spacecraft. So Perseverance is the rover. You can see a picture of it right there. It looks very similar to previous rovers that we have sent to Mars. These rovers are very big. Maybe it's hard to see from the picture, but these are like the size of a car, like a Mini Cooper. They weigh up to a ton, right? And they're very, very, very expensive rovers. The main purpose of these rovers, why do we send them to Mars, is to actually look for signs of life. That's one of the main aspects of these missions. And then the other one is to understand how Mars formed and the history of Mars. That way we can learn from Mars and maybe avoid problems or things that happen to Mars in another planet, right? And before I get started of what I do at JPL or how we actually test these rovers prior to launch, Andres asked me to talk a little bit about myself. I'm originally from Mexico, born and raised in Mexico. Since I was a little kid, I knew that I was a little interested into this aerospace or technology kind of things, right? I remember flying with my family in model rockets where you used to put these gunpowder cartridges and then the rocket will fly off. That's when I was a little kid. When I was about 15, I continued developing this aerospace hobby that I call, right? At some point, I started developing my own rocket engines, you know, making the gunpowder, the black powder, and testing in my house, blew up a couple of stuff that my mom wasn't super happy. But I kept doing that. I was 15, I was very naive, and I was not very careful. At some point, I was making this new concoction that I was trying to make into a rocket engine. And the thing blew up in my hand. It gave me a third-degree burn on my right hand, and it landed me on the hospital for a whole week. At this stage, I was sure that chemistry or rocketry was not going to be my thing. You know, it was too dangerous. So I shifted focus a little bit, and I started doing robotics. So when I was in high school, I started developing robotics with Legos and whatever electronics I could find, you know, Arduinos or things like that, and I started developing those skills in that way. When I was in high school, almost transitioning to college, I kind of knew that I wanted to develop technology, you know, be an engineer. So I started looking at a path. I was going to do engineering in Mexico, in my college in Mexico. But then I also knew that I wanted to do a graduate school, right? Maybe study a master's or a PhD at American university, because the technology development programs in Mexico were not up to par to what the US has. So I started developing a plan, and I knew that I needed these extracurricular activities to strengthen my application to these universities that I was gonna, you know, apply for in a couple of years. And some of these activities ended up being robotic competitions, like the one that you can see there, right, where I won some first places. But then other ones, very important to me at least, were some what they call research internships. So this is what basically a little exchange, right? You go for a summer to a US university and you study or develop an engineering project during the 2 months in the summer. And that way you learn practical skills in engineering. Otherwise, it will be really difficult to do. And this can be done obviously for people living in the US as well, right? So you go, instead of going for a vacation in the summer, you go to a university and then you work in these very cool projects that help you strengthen your application for future places that you want to work at. So the first place that I exchanged was in Pittsburgh, in Carnegie Mellon University. We were developing a lunar rover, like you can see there. The next one was at MIT, a university in Boston. I was working with thrusters for CubeSats, which are the new trend of very, very small satellites. And then the third one was a robotics company in Silicon Valley, actually in San Francisco. So with these 3 internships, I then applied for grad school once I was done with my college. And then I was lucky enough to be admitted at MIT, which is a university in Boston. And in here, I started working with CubeSats. So CubeSat is, Andres can tell you everything about them, but CubeSats are the new way that we're going to make satellites, right? Satellites are very big and very expensive. We're trying to make them very, very small and very cheap. So they end up being the size of a baseball. So that cube that you see in that picture is more than the size of a baseball, right? And at the laboratory at MIT, where I was doing my master's and PhD, we were developing electric thrusters for these types of CubeSats. The CubeSats, once they're in space, they need to be able to move around. You cannot use propellers, so you have to use these very small rocket engines, right? In our case, they were electric rocket engines. So you put electric energy, and then ions or electric particles will come out of the satellite and it will move. And that's how these satellites will move in space. Obviously, before we send these CubeSats to space to test the thrusters, we have to measure them and characterize them and test them here on Earth. So my whole PhD, the project of my PhD, was building a very complicated machine that was able to measure the thrust and the performance of these very, very small thrusters. Right? You can imagine these thrusters produce the force of the weight of a mosquito. Very, very, very small forces that are very, very difficult to measure. So I had to build a machine that used magnets and levitation to actually be able to measure these very small forces. With that, then we were able to send 4 CubeSats into space while I was doing my master's. And these were the first CubeSats with this very specific type of thruster technology that were launched into space. This thruster technology became very popular, right, within the community. And myself and some colleagues from the laboratory actually made a startup to try to commercialize these thrusters, sell them basically, right? And this company, Action System, still going strong today and still selling these thrusters to people. At the end of all this, 5 years have passed since I started my PhD. It was time to become an adult and apply for an actual job, right? And that's how I ended up at JPL. After MIT, I applied for a job at JPL. And then I was lucky enough that they accepted me. And that's how I started working on Perseverance, on this rover. So now let's talk about that. So Perseverance, again, is the rover that is going to land tomorrow on Mars. Very, very exciting. This rover is very big. It's 1 ton, size of a car. And the mission of this rover is to go to Mars and collect samples and prepare them in such a way that we can get them back to Earth. This is going to be the first part of a whole campaign that is going to try to retrieve samples from Mars and get them back to Earth. The way that this is going to work, as you can imagine, is very complicated, but the idea is that when the rover lands, it starts moving around. When scientists see a very interesting rock, the rover is going to drill into it, and it's going to take out a piece of rock, more or less the size of a finger, right? So a cylinder kind of shaped finger-sized rock. And it's going to move this rock into its belly, and inside of the belly of the rover, you have this sampling system that is going to basically seal this piece of rock into a hermetic tube, a metal hermetic tube, like a can. So you can think of it that the rover is going to go drill samples on Mars, and then it's going to can them in metal tubes, right? And we're going to do this a couple of times, about a little bit less than 40 times. We have 40 of these cans. And then these cans are going to be, prepared in such a way that a future mission in a couple of years launches from Earth, arrives to Mars, and with a very small rover, we get those cans, right? Those cans already have the samples hermetically sealed. Another rover is going to go get them. And this very small rover is also going to put them in a rocket. That mission that went from Earth to Mars has a rocket with it. And then this rocket is going to launch from Mars, right? This is going to be the first time that a rocket launches from Mars, not the other way around. And it's going to end up in Mars orbit. That very small rocket doesn't have enough fuel to go all the way back to Earth. So we're going to end up with a rocket with the samples, right, orbiting Mars. So then in a couple of years, another mission comes back from Earth and pick up the samples in space above Mars, and then eventually returns them to Earth, right? So there's going to be a total of 3 missions Perseverance, the first portion of this mission that we need to, I guess, accomplish in order to get these samples back to Earth. And the motivation, as I said, is to study science of life, right? These rocks that we bring back to Earth, we're going to be able to study them with a very peculiar and detailed instrument that we have on Earth that we cannot fit on a rover, right? Like microscopes and things like that. So we're going to have a lot of time and a lot of very expensive machines that can actually analyze these rocks very carefully and tell us if there is any signs of life, microbial life, for example. And that's more or less what the rover is going to do. To test it, I was part of the team that tested this sampling system, you know, the hermetic cans and the drilling system. To test it is complicated. We have to ensure that it works perfectly. The rover is very, very expensive, and it will be a very, very, you know, it will be a shame if we send it over there and the drill doesn't work, right? So therefore, we have to test it very, very methodically for years and years. And the complication of testing is that when we're building these things, right, everything is being built at once. Perseverance started, you know, its life almost 10 years ago in 2012 after Curiosity landed on Mars. And we designed Perseverance on paper and on computers, all digitally, for about 5 or 6 years. We only started building stuff maybe 3 years ago. And the problem is that when you start building, everything starts built at the same time. The arm is being built in that building. The camera system is being built over there by this other team. The rover computer is being built by, you know, your friends, etc. And everybody's building these parts at the same time. But before we put these parts together like a Lego, we have to ensure that each of those parts works and talks to each other, right? So for example, the robotic arm is moved by the rover computer, but we cannot just attach the rover computer and the robotic arm and hope that it works, right? We have to test it before. So what we do to expedite this process is build ground support equipment, basically boxes or things that mimic other pieces on the rover, and those pieces actually do not fly to Mars, right? So for example, my project was basically mimicking the rover computer in such a way that we could actually move the robotic arm of the rover before it launched with something that is not the rover computer, right? It's just simulating, it's pretending to be. So we build these boxes that you see there, and then we plug the robotic arm into it. And then from a regular computer, we're able to move the robotic arm in the same way that the rover computer would have commanded it. And this way we ensure that the robotic arm works. So when we put it together with the actual rover computer that is very, very expensive, we know that it's going to work, or we have confidence that it's going to work. And here I wanted to make a little parenthesis, right? I mentioned when I was in high school, I was doing robotic competition, and I was using hobby grade electronics and parts, you know, Legos and things like that. Maybe some of you here in the audience have used those things before. And I found it very, very interesting that in these boxes that were used to test the Mars rover, we actually have the same type of hobby electronics that we use to make these robotics, these robots that I made 10 years ago, right? I'm very surprised of this because when I was in high school, I thought, you know, people that work at NASA probably just have super secret equipment that nobody else knows how to use. But no, actually in these boxes, the ones that tested the robotic system for Perseverance, we have Arduinos inside. We have these modules that some of you might have already touched, right? And I put those in there because they're easy to use and they work. So whenever you are, you know, exploring whatever you like, don't feel like people in certain jobs have secret equipment, right? We use the same things. So keep on building those skills, very useful. So that's on the rover. I also want to talk a little bit about Ingenuity, which is another very cool aspect of this mission. Ingenuity is a Mars helicopter. It's going to be the first Mars helicopter to fly on another planet, right? And this helicopter right now is being brought on the belly of the rover. It's covered by a protective case. When the rover lands, a couple of days afterwards, it's going to deploy the helicopter. The rover is going to move far away from the helicopter, and then we're going to attempt to fly this helicopter for the first time on Mars. Flying on Mars is really, really hard, which makes this helicopter a technological marvel, to say, right? And why is it hard to fly on Mars? Well, the air on Mars is very thin. There is not a lot of air particles to grab yourself to. You can think of it as, you know, if you were in the top of Mount Everest, where you need a mask to breathe because the air is so thin, that's the same thing on Mars, right? But it's at the surface. So then the propellers of this helicopter have to be very big, and they have to spin really, really fast to be able to push enough air, which there's very little of it, right? They need to push enough air to create thrust to actually fly up, right? So that's why this helicopter might look oversized, right? The propellers are 3 feet in diameter. They might be bigger than what you see in a small drone here on Earth, but that's just because flying on Mars is really, really hard. Now, Mars does help us on flying because he has a weaker gravity than Earth, about a third, right? So things on Mars weigh less than things on Earth. So that helps you fly because the helicopter is not as heavy as it would be on Earth. But still, the thin air really makes it still really hard to fly. So how do we test a Mars helicopter here on Earth, right? The first thing that we need to do is we need to simulate the atmosphere, the thin air. And we do that by putting this helicopter inside very, very big metal tubes that we call vacuum chambers. This picture is actually taken inside of one of those tubes, right? And then from the tube, we basically suck up all the air. We make a vacuum, kind of like space. And then we inject a specific type of gas at a specific pressure to simulate the atmosphere on Mars, right? So we pull a vacuum, and in this case, we inject carbon dioxide because the Martian atmosphere is it's almost pure carbon dioxide. But we inject it very carefully in such a way that we end up with a thin atmosphere of carbon dioxide, right? Replicating the conditions on Mars. The other thing we need to do to test this helicopter is to mimic the gravity on Mars. As I said, Mars gravity is weaker than Earth. So then we need to either make the helicopter lighter, which is really hard to do because every single part of the helicopter is essential and it cannot fly without it. And they already made it as light as possible. So it's not like we can take, the legs off. So we need to help the helicopter fly, right, to mimic that weaker gravity. And the way that we ended up doing this is we had a little string, literally a fishing line, right, connected to a motor at the top of a beam. And then the motor will pull up the string up and down, providing a constant force that basically mimicked the weaker gravity on Earth. So we basically had a machine that, when we turn it on, the helicopter will think that it's on Mars gravity. It will be lighter, if you will. And this was very interesting because the fate of this whole project, right, the first test flight was literally dangling from a string, from a fishing line, very, very thin that you can barely see. Here's a picture of it. So that's the helicopter, the real helicopter being, supported by this very thin fishing line. And well, if that fishing line or the knot or the motor up there fail, then the whole helicopter would have crashed. So it was a very, important and nerve-wracking project. Eventually, the whole system worked. The helicopter flew beautifully inside this vacuum chamber with the gravity offload system. That's how we call this machine. And that gave us confidence that this helicopter is going to fly on Mars. So tomorrow, when Perseverance lands, it's gonna carry with itself a helicopter on the belly. And then a couple of days later, if you watch the news, where they're going to deploy the helicopter from the belly, and then we're going to attempt to fly for the first time on Mars. So very exciting times. So that's more or less a little bit of how we test these robots on Earth prior to sending them to Mars, right? We have to mimic and simulate a lot of things to make them think or to make them feel like they're on Mars, because that's what we're actually going to operate the robot on. And it takes, years and years. So I mentioned this in 5 minutes, but, the Perseverance has been tested for the past 3 or 4 years, and the helicopter has been tested for the past 3 years. So it's a whole campaign of tests to ensure that these robots work perfectly before we launch them. And lastly, just to finish, Andres asked me to talk a little bit what's in the future, at least for me. Mars, as you can see, is a very popular place, right? We're sending a helicopter to Mars. There's a rover that is going to take samples from Mars. China is sending a mission to Mars. And the Middle East is also sending a mission to Mars. It's a very popular place. And we have sent up to now 5 rovers on its surface, and we're going to bring samples back, right? At that point, I'm going to call Mars conquering in a certain way, right? The next logical step after that is for humans to step on Mars, right? That will be the next thing to do in decades or a couple of years. So then at that point, Mars is kind of like, okay, we know how it works. We know either that there's life or not life at that point. So what's out there? What's after Mars? And with that, I want to talk about these very interesting places in our solar system that we call ocean worlds. Ocean worlds are basically bodies in our solar system that we think have liquid water in a certain area in their surface, right? And the most popular ones are frozen moons from Jupiter and Saturn. Saturn and Jupiter are very big planets. They're really far away from Earth, but they all have a lot of moons. Jupiter has more than 10 moons. So some of those moons actually end up being like snowballs. They're basically pure water that is frozen in space because it's very, very cold. And from the outside, they look like an ice ball, right? Like a snowball. But actually, if we look carefully into these bodies, we have evidence to believe that there is liquid water underneath a very, very thick layer of ice. We're talking about miles of ice, right? Miles and miles of ice on the surface. But then underneath that, we have liquid water. And we're very excited about that because, again, a lot of the reason that we send these spacecraft to other planets is to try to search for signs of life. And if we know there's liquid water underneath a very thick ice shell on these bodies, and if we know that in Earth, whenever you have liquid water, you have life, right? There might be some life in these ocean worlds out there in Jupiter and Saturn. So that's what we're looking at next, right? These are obviously very different from Mars. You're talking about icy worlds, really, really cold. They're really, really far away. And to get to the ocean water, to the liquid water underneath the miles and miles of ice, as you can imagine, that's very, very complicated, right? So you might see rovers on these bodies on the surface, but the very, very interesting thing is to send some sort of drill or probe that actually penetrates the very thick layer of ice on top, and then eventually ends up in the water, so you can actually study the liquid water and find or try to look for signs of life. So if anybody of you are interested in a NASA career in the future working on space, maybe in 10, 15 years, we're going to be working on this. How do we make a robot or a spacecraft that actually goes inside an ocean world, penetrating miles and miles of ice? So that's going to be a very interesting challenge that you guys might be able to work in. And that's all I have. So with that, we can open it up for questions. Thank you so much.
All right. Thank you, Dr. Mier-Hicks. Mr. Natividad, Ms. Martinez, can you guys assist us with the questions?
Sure. I saw Ariel Diaz. Would you like to ask your question? Ask to unmute. Go ahead and ask your question, Ariel Diaz. Hi, Ariel. Let's see. Oh, a little louder, Ariel. A little louder. We can't hear you.
How do you make a rocket ship?
Did you say?
How do you make a rocket ship?
How do you make a rocket ship? Well, they're very hard to make, right? A rocket ship is just basically a metal tube with a lot of like explosive material, like fuel. So you have to, very carefully burn this fuel to provide the fire that comes out of the end of the rocket. And that's really hard to do. And if you do it wrong, that fuel might, explode. And that's how you see a lot of these explosions in rockets. So making rockets is really hard. They're very big and they're all full of very dangerous chemicals and fuels. So you have to be very careful of how you burn them. But that's more or less how rockets work.
Thank you. Juan Daniel, would you like to ask your question? Juan Daniel?
What will happen to the rover when the humans are in Mars?
What will happen to the people on Earth when the humans are on Mars?
No, what happened to the rover when the human lives on Mars?
I see. So the rover has a nuclear battery with it, and we expect that to last about 15 years, right? So the rover is going to be, roving around and doing its stuff for up to 15 years if everything goes according to plan. If humans are on the planet while the rover is still operating, I guess it's unclear. I don't know if we will still drive the rover because maybe humans can walk and do whatever the rover is going to do faster, right? I don't know exactly what's going to happen then, but I can tell you that the rover is going to be very useful for us to study the planet prior to humans landing, right? Before you land humans on Mars, you need to know what type of soil you have, how strong it is, what type of atmosphere you have. Can you take your helmet off and breathe the atmosphere on Mars, right? And all these questions are answered by rovers and other missions that we send to Mars to study the planet before humans get to Mars.
Thank you.
We have a question from Sophie, who's 5 years old. She wanted to know how long it took Perseverance to get to Mars.
About 6 months, 6 or 7 months. We launched Perseverance back in July from Florida in a very big rocket. And then since Mars is so far away, it took about 6 months to get there. And we have to imagine that once the rocket leaves Earth, it's traveling faster than a bullet. So it's going really, really, really fast, but because Mars is so far away, it still takes about 6 or 7 months to get there.
We have another question in the chat. What's the job of the helicopter?
The job of the helicopter is to demonstrate that we can fly on Mars. It's an experiment, right? This is the first time that we send a helicopter to Mars, and the whole purpose of it is to be able to prove that we can fly. If we can fly successfully, then maybe there's a future mission later on with a bigger helicopter that now we can put, very fancy cameras or a lot of instruments, and then we are able to explore the whole planet in a more expedient fashion.
Okay, it looks like we have another question. Bronson wants to know, what does the sky look like on Mars?
It's grayish or orangish, depending on what you, I guess, look for it, right? Mars has different air than Earth, right? It's carbon dioxide. On Earth, we have nitrogen. So that makes the color a little bit different. And because the atmosphere is so thin, you don't have the blue sky that you're used to on Earth. So you mainly see the sun, shining through, and then the dust particles on Mars, which are orange, that gives it a little bit of an orange hue. Interestingly, though, when there's a sunset on Mars, right, because there's also sunsets on Mars, the atmosphere is different, and it creates a bluish sunset instead of an orange sunset that you will see on Earth. So sunsets on Mars are actually bluish.
Okay, it looks like we have some more exciting questions in the chat. Are we working with other countries as a team, or is it a Mars race?
We are working as a team. There's instruments and portions of Perseverance that were developed elsewhere. For example, the antenna that we use to communicate was manufactured and designed by Spain, right? For the previous rovers, for example, Curiosity, a lot of the instruments that it has, cameras and spectrometers and things like that, all of those were manufactured and designed in different parts of Europe. So we are kind of like an international team trying to put this spacecraft together. So we're definitely a team. There's also a little bit of a race, right? Who gets more rovers into Mars, right, or faster. But overall, I think it's a team effort between a lot of countries.
Okay, it looks like Tron and Juliet have a question. So if you would like to go ahead and unmute yourself, you can go ahead and ask.
Could a future rover bring water to Mars to see how it reacted to Mars's atmosphere?
Yes, we can definitely send future rovers to see how they react on Martian atmosphere. The fact that we have sent already 5 rovers on Mars, so we already have 5 rovers. They have already studied the atmosphere. So right now, what we're doing in that, topic is, for example, how can we use the atmosphere on Mars to help humans live in Mars? And for example, Perseverance is going to carry a machine that is going to try to convert the carbon dioxide on Mars atmosphere, basically smoke, right, into oxygen that humans need to breathe. Because there's very little oxygen on Mars, and humans need oxygen to breathe. So maybe with a machine, we can convert the type of air that is on Mars and make it, proper for humans to actually breathe.
Okay, it looks like Alan has a question. Go ahead and unmute yourself and you can ask it.
What happened to the humans on Earth when they go to Mars? Other humans go to Mars?
That's a very interesting question. We don't know all the things that are going to change on a human when we send them to Mars, right? The humans are going to take a long time to get to Mars. Perseverance took 6 months. Humans might take a little bit shorter. We might make the ride faster with a bigger rocket, but they're still going to be in space for a very long amount of time, right? And being in a very small spacecraft confined in space makes people go crazy. So we're currently researching how we're going to be able to keep the person in that spacecraft happy, because it's going to be in a very long car ride, basically. And then once we land, we have to have a whole, kind of like house prepared for them. We need to have water and food for them already there, right? And then we also need to have oxygen so they can breathe, and we need to have heaters so they don't get too cold. So there's a whole list of preparations that need to happen before we actually send humans to Mars. And then the other very tricky aspect is that it's really, really hard to bring humans back from Mars, right? You need even a bigger rocket to be able to bring them back. So maybe the first people that go to Mars actually just live in Mars and they don't come back to Earth. But yeah, all of this is being researched.
Are animals gonna come too?
Maybe. I'm sure dogs will like to be in Mars, They're the best friend of a human, so why not?
Okay, we see Alanis Ramirez. Go ahead and ask your question, Alanis Ramirez.
What happen if we had to live in another planet because Earth had a slow reaction or something because the climate change got colder or something like that?
Oh, can you repeat it one more time? Can you repeat your question?
Alani, sorry.
We have to live in another planet because the Earth had something happen to the Earth.
Yeah, Alanis, do us a big favor. Can you put it in the chat? Because it's not coming through. We can't understand what you're saying. Hey, let's all give Dr. Fernando MierHicks a virtual round of applause. Please help me thank him. What an amazing story, Fernando. I'm really glad that you were able to join us. Incredible work, and being so young, you're just getting started. I'm really ready to see all the major breakthroughs that you're going to be working on. So I'm excited. Thanks for joining us. Let me, for those of you assisting today, I want to thank you for joining us too. I think you can also agree that we had a great talk today by Dr. Fernando MierHicks. What an amazing story, and also tomorrow, the rover that he's been working on is going to be reaching the Mars surface. So I want all of you to come back tomorrow so you can celebrate the incredible work of Dr. Fernando MierHicks and his team. Tomorrow they arrive on the Mars surface, and this rover is going to start moving on Mars for the first time. Tomorrow we're going to have Dr. Dave DeMarais, whom some of you participated in his talk. He's going to come back and he's going to be the master of ceremonies, helping us understand what's happening behind the scenes and all the way through the landing. Okay, so please come back tomorrow. And also don't forget that we also have 3 more presentations scheduled for next week. So next week we're going to have Sergio Valdez present. He's going to present a talk on the Ingenuity, the Mars helicopter. And we have 2 other talks also on Wednesday and on Thursday. So with that, I would like to thank you for joining us today. I want you to keep doing your homework. I want you to keep listening to your parents. I want you to come work with us. And Dr. Fernando MierHicks, he's gonna need you to come and help him. He has a lot of work. Okay.
Definitely.
And maybe some of you will help us here on Earth. Maybe others will be astronauts, just like this little girl will be one day, and going to space and maybe all the way to Mars. Okay. So keep doing your homework, keep working hard, because Dr. Fernando MierHicks did all his homework. That's why he's at NASA JPL. Okay? Listen to your daddy and your mommy, your parents, everyone who's telling you to do your homework and your chores. All of that is very, very important. Okay? So have a good day, stay safe, take care, and we'll see you tomorrow. Once again, Dr. Fernando MierHicks, thank you very much.
Thank you, everybody. Bye-bye.
Thank you, and congratulations. Thank you. Bye-bye.
Can Alani say your question?
Where? Mr. Natividad, can you open up another break room real quick?
Give me a second.
Thanks.
Thank you.
And Danielle is with
Thank
us.
you.
Thank you. Take care. See you tomorrow. Come back so you can see the landing.
Thank you for answering my question. Don't leave Alani there. We need a breakout room. Bye.
Bye.
I need to stop.
Okay.
Ms. Martinez, you can click on it to join if you want. I
All
signed
right.
you.
Thank you.